how to determine the regression equation of y on x using the method of least squares. That's least square method. So regression equation of y on x is normally presented in the form y is equal to a plus bx, where a and b are constants. They are the ones that we are looking for. So for us to determine the value of b, we say b is equal to n summation x y minus summation x summation y over n summation x squared minus summation x squared, like that. And for us to determine the value of a, we say a is equal to the mean of y minus b times the mean of x. These are the two formula we use to get the values of a and b. Now, suppose we have an equation. Suppose we have values for x and y as follows. We have here -1, -1, 0, 1, 2, 5, 5, 11, and 10, 21. So the first thing we need to do is to come up with columns which will be able to give us these values that we need to calculate the values b and a with. So we come up with a table of x, y. Then if we look at this one, we need n. N refers to the pair of observations. 1, 2, 3, 4, 5. So our n is 5. Then we need summation xy, a total of column xy. So we need column xy. We also need summation x. That is the total of column x, which is already here. Column x is here. The total will be the one here to be used here. Then summation y means the total of this column here. Down here we have n, then we have summation x squared, the total of column x squared, meaning we need column x squared, like that. So those are the columns we need, because this one is the total we shall get down here that will be used there, and these are the means. So let's have these values here: -1, 0, 2, 5, 10, -1, 1, 5, 11, 21. So xy means a value in column x times the corresponding value in y in column y. So this times that, giving us 1, 0, 10. This times that is 55. This times that is 210. X squared means the square of these values here. So we have 1, 0, square of that is 4, square of that is 25, the square of that is 100. So if we sum them, we shall have 15, 17, 16, 21, 32, 37, 38, 37, 210, 265, 275, 276, 125, 129, 130. So we can now use these values to calculate b, and we shall say b is equal to n, which is the pair of observations, which is 5, 1, 2, 3, 4, 5, 5 times summation xy, the total of column xy is this one, 276, minus summation x, that means the sum here, 16, times the sum of y, summation y, which is 37, all over n is 5 into summation x squared means the total of column x squared, which is 130, minus summation x, the total of column x, which is squared, so 16 squared. So if you work out this correctly, you'll get 1380 minus 592 all over this times this, giving us 650 minus 256. So that boils down to 788 over 394. Then this cancels here. Once it cancels here twice, so the answer is 2. Our B is 2. Then we now come and start doing or calculate for A. We need the mean of y and the mean of x. So we shall say the mean of x will be equal to the sum of column x, which is 16 over 5, and that gives us 3.2. Then the sum for the mean for y will be the sum of y, which is 37 over 5, and that will give us 7.4. So we can say now, therefore, A will be equal to the mean of y, which is 7.4, minus B, which is 2, times the mean of x, which has been calculated and found to be 3.2. So that will be 7.4 minus 6.4, giving an answer 1. So we have found the value of A and the value of B. Therefore, we can write the regression equation of y on x as y is equal to, instead of A, we get the value for A, which is 1, plus 2x. And that becomes the regression equation of y on x. Thanks for watching.